This is Algebra 2, Section 7.5, Day 2. We're going to be talking about the change of base formula. Before we do that, we're going to review a little bit from what we talked about yesterday. So you go ahead and expand log base 5 of x squared over y to the 1/3 power. Something you should notice here, we have a fraction. So we're going to say log base 5 of x squared minus log base 5 of y to the 1/3. Remember, 1/3 is the same thing as a cubed root. So next we're going to take our exponents and bring them in front to get 2 times log base 5 of x minus 1/3 log base 5 of y. That's as far as we can take that. Just because this is a fraction doesn't mean we set up anything differently. It's just the fraction of what a logarithm's taking. Now we're going to condense. To condense, that means that we're going to group it together and put it in with one logarithm. So we're going to take the properties that we've learned and work it backwards. So we're going to take the number in front and put it up as our exponent. And then working from left to right, these are all log base 10. They are the common log. So because they all have the same base, we can use these properties that we've talked about. We're going to combine or condense these two logs together. 2 to the 3rd power is 8. Now that we have the 3 sitting out there minus log of 3, because again the bases are the same, we can combine. So we're going to get the log. 9 times 7 is 72 divided by 3, and we know that 3 can go into 72 to become log of 24. So that's condensing that problem. Now your calculator can do your calculator can be helpful for calculating logarithms. And for us to calculate using a typical calculator, we can't change what the base is of our logarithm. The Texas Instrument 84, TI-84, there are ways that you can change that bottom base. But want to be sure that you're familiar with the change of base formula, which is typically we can just say log of A over log of C, and that's a fraction. Now sometimes you'll see that they'll put another letter in for the base. If you looked in the book, they'll probably have a value. You can put any base of the logarithm you want. Typically we would want a common log because that's the easiest to use, and you can use your calculator for that. The A value is what you're taking the logarithm of, and your C value is the current base. Notice how there's a log on top and a log on bottom. when we did our work with expanding and condensing, we did not write a log for the numerator and the denominator, but with the change of base formula you do. So what would this one look like? We would take the natural log, because it's ln. You could get away with the log. In this case, it doesn't matter what the base is, so you don't really need it to be a base of e, but typically we would keep it with ln. So notice how the a is higher, so we're going to put the a on top, and notice how the c, which is essentially e in this case, so with a natural log, actually with a natural log you could calculate out right away what your value was, because a calculator can do natural log. But trying to get used to how we put a's on top and c's on bottom, the base of a natural log is always e, so this format seems a little silly, but nonetheless this would be the pattern that you would write it in. So we're going to evaluate these, and we're going to use the change of base formula. So notice that we're doing log base 6 of 22. 6 to what power equals 22? That's the big question. So our calculator can only do a common log, so we're going to try this change of base formula. We're going to take the log of 22 divided by the log of 6. And no, the logs cannot cross out, so we can bring in our scientific calculator and say log of 22, figure out what that number is, divided by the log of 6, and we get 1.725. Now that would be an approximation, so it's usually best if you show approximately as your answer, because it's not the exact answer. Now notice, if I do the 6th power, actually the base of 6, to the power of our answer of 1.725, what answer would you expect we'd get? We should get 22. Now if you only used a rounded number in there, 6 to the 1.725, you're going to get a number that's not quite 22 because it's rounded. You're going to get a rounded number. So that's why it's good to use the answer button. You go ahead and try this part B. So we're going to find the log of 1.3 over the log of 5. And that should be approximately log of 1.3, that gives us that number, divided by the log of 5, gives us 0.163. Now let's test that. Let's take the 5 and raise it to the power of that whole answer. So I like to use the answer button. What answer do you expect to get? 1.3. Right on. You go ahead and do this last one. So we know that the log of 9 over the log of 4 is called the change of base formula. So we're going to find the log of 9. Here, if you would like to use parentheses, you say log of 9 divided by log of 4, and you wouldn't have to hit enter. So we get 1.58, maybe 1.58. Well, if they're asking for the nearest thousandth, we should take that to 1.585. Now, when we test our answer, we're going to take the 4 raised to the answer. Don't use a rounded number. And you should get exactly what we're looking for. Exactly the 9. Now we're going to use this formula to help us answer this question. Under certain conditions, the wind speed, which is in knots, at an altitude of h meters above a grassy plain, can be modeled by this function. So here's our wind speed in terms of our height is equal to this equation. Twice the natural log of 100 times the height. What is the wind speed at an altitude of 17 meters? So, what is the wind speed? That's S. When the height is 17, that means you're going to do 2 times the natural log of 100 times 17. That's going to come out to be 2 times the natural log of 1700. And when we do the natural log of 17, or 1700, we get this 7.438. So the natural log of 1700 is 7, sorry, 0.438. Now, for you to calculate this, you do not want to use the rounded number 7.438. You want to use the real answer that's in your calculator. Don't use rounded numbers to get your work. Don't use rounded work to get your answer. So we're going to take the real answer here and say 2 times the answer. The answer button on the TI-84 is next to the enter button, next to the point underneath the 3. It's on the negative. So we're going to get 14.877. For this last question, for a sound with intensity W, the loudest the loudness of the sound in decimals is given by the function right here, where W to the 0 is the intensity of a barely audible sound. So this is telling us what its value really is. 10 to the negative 12th. You're going to need to know that number. So the intensity level of an electric guitar is 10 to the 2.8 watts per square meter. Find the guitar's loudness. Well, the loudness, if the intensity, which is the W, is 10.28, follows this formula. 10 times the log of our loudness, which is 10 to the 2.8, over W to the 0, which is the lowest sound possible. So what does it mean to have a negative exponent? A negative exponent means move it up to the numerator. So now we're going to take that and we'll add the two exponents together. So that's going to give us 10 to the log of 10.14.8, which is going to be an approximation again, because we're going to get this crazy decimal. So we're going to type in 10 times the log of 10 to the power of 14.8. And we get 100, actually right on the button, of course, because we're multiplying by 10, of course. So that's going to be exactly $148. How could we have known that? Because the base here is 10. So when we do these two bases the same, we get the answer of 14.8. And when we multiply 14.8 times 10, the decimal spot moves over 1, and we get 148 decimals.